One other thing that I want to discuss about Lab 2 is how we're going to create our input voltage. So in your simulation and what we'll see in the lab is, remember, we're going to need a negative and a positive power supply to power our op amp. So in your simulation, you'll have negative and positive power supply connections on either side there. But we also need some type of input voltage that's being input to either our inverting or non-inverting terminal. And so due to a limited amount of power supplies in the lab, we're not going to have enough to have 3 power supplies for each station. So one way that we can get around this is we can use the same power supplies that we're using here, one or the other, and we can use a voltage divider network in order to create the input voltage from that supply. So let's look at how that is what that's going to look like here with a simple voltage divider network. So let's come over here and put in a DC source. So our source library, and I want VDC. So I'm going to rotate this a couple times. So let's say this is our positive source, for instance. So we have our positive source up here, and so it's going to have some value. So let's say 6 volts, for instance. Okay, so we've got 6-volt source. And so we're going to have a resistor as well. So if we have a voltage divider network, of course, the simplest one is just 2. So let me select my analog library. Is just 2 resistors. So let's put in 2 resistors, rotate, and let's put one more here. Okay, and so we're going to need some ground. So let's put some grounds in here. And so we can put in multiple grounds if you want your circuit to look a little cleaner. So for instance, I can put a ground down there, and I also put a ground up here. Okay, so I'm going to hit escape to stop placing that, and let's see if we can zoom in a little bit here. So let's wire this together. So for instance, let's say I have this 6-volt source, and I want my input to be 3 volts. So actually, let me zoom out because that's a little bit difficult to see. So let's stop wiring. So let me put a net alias just to be clear about where our input is. So let's say this is our input to the op amp. So this is our input, would be right here. And so the reason for that is because we can control what this voltage is based on the values of these resistors. So if we wanted our input to be 3 volts, all we'd have to do is make these values equal, and then half of it is dropped across R6. So it seems pretty straightforward, but something to keep in mind is if we look at our op amp circuit, and so it's going to be different whether we're using non-inverting or inverting, but basically what we're going to see is wherever we have our input, well, in this case, we don't have our resistor, but for our inverting configuration, which you'll be doing for the lab, we're going to have a resistor and then our input voltage on the other side. So this resistor is essentially connected to, it's going to be connected to one of our op amp input terminals, and because the other input terminal is going to be grounded, it's at a virtual ground. So what we need to do to represent that is we actually need to put in another resistor. So I've got one too many there. Let me escape and let me move this guy up here. So we have another resistor which is coming off of our input voltage, and it's going into our op amp, which would be over here, but this terminal is going to be at a virtual ground. So we can represent that as just another ground point. So let's put in another ground, and we can rotate that if we want, and let's escape and then wire these together. So we see now we have this connected here, and this connected to ground. And so if we want, we can label these so it's a little clearer. This would be, for instance, our R going into the op amp, whereas these would be part of our voltage divider. So what we'll see in the lab is we can actually use, this will be a trimmer potentiometer, so it's an adjustable resistor. And this is just going to be the resistor for our voltage divider. So we can set a fixed resistor for this voltage divider. We can adjust this trim pot up here, but we need to take into account this resistor, which is part of our design for our amplifier circuit. So what we can see is this, as it's labeled R7, is actually in parallel with this volt div resistor. So When you're adjusting or calculating desired values for trim pot to get a certain output voltage, you need to account for this resistor here as well.